Today I'm going to talk to you about the general properties of temperature. Here's a thermometer that is calibrated both in Fahrenheit and Celsius. In boiling water, it measures 100 Celsius, or 212 Fahrenheit. In ice, it measures 0 Celsius, 32 Fahrenheit. And the human body temperature is 37 Celsius, which is 98.6 degrees Fahrenheit. If you were to graph these points on a Fahrenheit versus Celsius chart, you would get a straight line of melting, body, and boiling temperatures. Using y equals mx plus b, we get y, the Fahrenheit scale, is equal to the slopes. Now the slope is 212 minus 32 over 100. That's the change of y over the change in x, times c, the x-axis, plus 32, the y-intercept, 32 Fahrenheit. Then the final equation becomes F equals 9/5 when you reduce it, times C plus B, 32 Fahrenheit. The well-known relationship between Fahrenheit and Celsius. So is that it then? 0 Celsius and 32 Fahrenheit, that's 0? No, there's another scale, the Kelvin scale, on which 0 is the coldest temperature possible. This device is called an absolute zero apparatus. It's a cask of air hooked to a pressure gauge. And right now, it's reading 20. When I put this in boiling water, the pressure increases at 24.5 psi. When I transfer it into the ice water, the temperature goes down and the pressure decreases. From the device, we get various points of data. Firstly, at 0 degrees Celsius, we got 18 psi. Later, when we put it in boiling water at 100 degrees Celsius, we got 25 psi. Also, room temperature fell in between at 20 psi. Following these points to where they hit the axis gives us a temperature somewhere between -200 and -300. An absolute zero, the coldest temperature possible, where there would be no pressure at all. Using y equals mx plus b, we put pressure on the y-axis and Celsius on the x-axis. P equals 0.07, our slope, times Celsius plus 18. We now set the pressure to 0 to find the coldest temperature possible. Rearranging, we get -0.07 divided by 18 equals C, our coldest temperature. In our crude experiment, it turns out to be -257 degrees Celsius. That's not too far from the actual measured temperature of absolute zero, which is now known to be -273 degrees Celsius. Now you might be wondering, what's absolute zero on the Fahrenheit scale? Well, using the equation we found earlier, we say Fahrenheit equals 9/5 the Celsius temperature of absolute zero, which is -273, plus 32. A little math shows you that the absolute zero on the Fahrenheit scale is about -460 degrees Fahrenheit.